Hi everyone, my name is Volodymyr and today I'll be presenting our analysis on the influence of threshold values in a real-time face recognition system. We will quickly cover the core problem, our system model, the experiments we run, our key results, and finish with our conclusion and future work plans. On this slide presented a simplified version of a general model for recognizing entities. In the article we considered only face recognition. The core idea is using a combination of a few machine learning methods like object recognition, object tracking, and object to embedding. As you can see, the program complex consists of few modules. Core 1 recognizes face rectangle of interest, in short, ROIs, and feeds them to arcface model to produce embedding representing faces. That embedding vectors used to recognize seen earlier faces or find new one. In the current version of the complex, we use more robust model for face recognition, which build face k-dots. Such model improve quality of ROIs, but require great computational resources. A live example of the system working depicted on the fifth slide. ROI is the target of the system. Also here is presented robustness of the system. As you can see, face rotation or object of the human head doesn't influence recognition, and still it's user 34. ArcFace is a convolutional neural network for transforming images to vectors. In our case, it's specialized on human faces. For face identification or separation, we use quite standard approach using cosinus metric and tau as measure of discrimination, threshold in other words. Low threshold means too strict face recognition. Slight changes lead to recognizing as different person. High threshold means too loose face recognition, even different faces recognize it as the same person, which is depicted on this slide. Example of high threshold. Obviously, as you can see, this is different people. For experiment, we use a pretty old and standard dataset called labeled faces in the wild. Examples of images shown on this slide. Dataset consists of 13,000 records. We also, for testing, created pairs of same person and different person to evaluate performance across various thresholds. Here is table of our observation depending on tau. As you can see, it's quite sensitive because tiny changes in tau leads to great changes in the system behavior. At low threshold, the system is too strict, failing to recognize over a third of genuine users. Here is the middle threshold. As you can see, almost 10% of cases were rejected in case of false rejection rate. In the middle range, it becomes usable only in controlled scenarios. Finally, we found the sweet spot is 0.06 to 0.07 range, which gives us the best balance of high accuracy and low error rate for practical use. you probably noticed that we hit in our testing 100% accuracy. We must admit that this perfect result is likely an artifact of specific test data. In real world, with varied lighting and abstractions, achieving absolute perfection is practically impossible. In conclusion, our work confirms that the threshold is the key to balancing security and usability. We established that for our system, an optimal operating threshold is between 0.05 and 0.07, which minimize risks for application like access access control and surveillance. For future work, we planning to optimize this framework for low-powered devices, and in the future, related to this work, we are planning to validate thresholds on different models and on different environment conditions. Also, we're planning to create a method for adaptive thresholds. Thank you for your attention. Please, your questions.